Guys, welcome back. So today I'm going to be showing something different. I thought I would show how to design a removable partial denture frame on ExoCAD. Now you have options to design partials using multiple softwares. My favorite, of course, would actually be 3Shape because the partial module on 3Shape is much more intuitive. But then there are a lot of people who do fantastic designs on ExoCAD as well. And since I have it here with me, I thought, okay, might as well give it a go. This video is meant for you if you are a dental student or a dentist or a laboratory technician who is just looking to get into partial design. Partials happen to be one of my most favorite things to work on, and it does need a little bit of background knowledge on what you're doing, but then once you do that, you're good to go. So let's just jump right in. The partial module for ExoCAD is also called as partial CAD. Now ExoCAD allows you to design teeth plus partials, teeth plus gingiva plus partials, but then I think for you to be able to stack them together and get a stackable RPD, you need a separate module. But then at this point you can still design teeth and your the framework together. However, you will not be able to design an upper and a lower in occlusion as of now. ExoCAD doesn't have that option yet, but what you can do is design a partial, either the upper or the lower, with the teeth in occlusion. Then once you're done with the designs, export the entire thing as a model and then use that as an antagonist to then work on your lower model. Or you can do it the conventional way, where you just design upper and lower frameworks, give it to the dentist, they make a bite, and then you go analog from there. It's completely up to you. Right now we're just going to be doing a Kennedy's class 1 partial. So let's just jump into the design. I'm going to be giving you the bare basic steps that you need to create a design. If you need anything more, you can always hit me up and we can discuss on how to take it up further. Now, since this is a model file, the teeth are already there, but I don't need them for now. I'm just going to be focusing on the partial design, so I'm just going to hide them. You have the rests prepared on or asked for on the distal of these particular abutments. The first step is going to be your blockout, which is basically telling the system where the undercuts are and how much of undercut I want for clasp retention. Now I'm just going to center the model. Usually what you want is a straight path of insertion. If you are going to change your path of insertion, then that would be determined by the tilt of your abutment teeth. So in this case, whichever teeth have clasps on them and rests on them would be considered your abutment teeth. Your premolars here and here, which would be your 3.4 and 4.4 would be your abutment teeth. So these teeth are relatively more or less straight, and so I am not going to be changing the path of insertion from the straight path of insertion that the system has already defined. If you have multiple teeth, then consider both the buccolingual tilt and the mesiodistal tilt of those teeth in order to get a path of insertion wherein you get a decent undercut on almost all teeth. Now what I mean by decent undercut is an undercut that is cervically placed and at the same time has a depth of around 0.25 millimeters or 0.01 inch, which is what you need for your cast clasps. Any deeper or undercuts placed very occlusally tend to have a lot of leverage forces on your teeth and abutment teeth and do cause periodontal destruction over a period of time. However, this is not always under your control as a laboratory. So in these cases, you can see that the undercut starts from the middle and gets deeper as you go down. In case you have a teeth which has, say for example, a very heavy buccal tilt, then the undercut would be placed much more occlusally. In that case, the best course of action, if you are a dentist, would be to go ahead, recontour those teeth, kind of correct the angulation, and then proceed for your partial design. However, if you're a tech and your dentist says, no, I've already done the preps, please go ahead, then you have to kind of work with what you got. So let's see, I'm slightly changing the path of insertion. These look good. You can see that the undercut on this side is much more severe. So I can actually enter a default value. I'm just going to reduce undercut to maximum undercut to 0.5, so that the undercut in the green zone is 0.25, which is what I want. So which is basically here and here. So this zone is basically what I need. Any deeper would be too much of engagement for a partial, and you're going to end up with a lot of problems, either be it fitting the framework or patient not being comfortable wearing them. So I'm happy with this. I'm just going to say apply, and the system is going to go ahead and block out the undercuts as you see them. And that is done. You can see that the wax has been applied, right? The next step would be for me to go ahead and scrape away the wax, because what the system has done right now is, based on the path of insertion, it has indiscriminately blocked out all the undercuts, right? There is no undercut left on the model right now. The only part of the CPD that will engage an undercut is the retentive tip of your clasp, right? Please remember this. I repeat it again. The only part of your CPD that is going to engage an undercut is going to be the retentive terminal or the retentive tip of your clasp arm. So if either it's going to be the retentive terminal of your I bar or your Y bar, or the retentive terminal of the retentive arm of your ACOS clasp or your simple circlets. So I am just going to go ahead and remove this wax, right, till I expose the green zone of the undercut. So there we go. Just removing a little bit of the wax. So you can see that I'm bordering on the yellow, which is slightly more towards 0.5 millimeters, which I don't want. So I'm just going to go and smoothen it, open the brush up. So the smudge tool removes, whereas the smoothen tool just kind of, merges off the border. So you can see that the little bit of the yellow has disappeared and I'm left with the green. And since this is going to be a circlet, right, I'm just having an approach till here. You could also remove only this much. It completely depends upon the amount of friction or the amount of clasp retention that you desire for your particular case. So again, going on this side, going to smudge, opening up the tool a little bit. So I'm kind of trying to match the outline of the clasp so that I get. So here you notice that I removed too much, so I need the arm to be a little on the top. I'm just going to undo, reduce the brush size a little bit, and then work my way from the top. Yes, this seems okay. I'm just going to go ahead, smooth it, and reduce the wax here. Now I have multiple options of smoothing here. I can also do a reductive smoothing or a subtractive smoothing, and it smoothens the wax, but at the same time takes away a bit. I'm just going to reduce the brush side and this. Yeah. So why I do this is because my clasp arm is going to be much thicker, right? It is going to occupy this entire width. So as it comes here, I don't want it engaging the deeper bit of the undercut here. I only want it engaging the 0.25 millimeter undercut here. So I'm just leaving a little bit of wax behind so that the bottom part of the circlet does not engage too heavily, and there is a little bit of relief wax kind of just working its way from underneath in that particular aspect or particular zone. So I'm just slightly reducing the amount of wax here so that there's not too much of a space. And yes, so we have thinned out the wax. As you can see, you can appreciate the difference between thickness of wax here and here, whereas no wax here, which will help us in kind of engaging the clasp into that particular area of the tooth. All right. Now the proximal plates, which are going to be coming here and here, already have an area of the tooth that is exposed. If, of course, your tooth has a very big distal concavity, which is usually very common in premolars, then you will notice that a lot of block out wax is added here. Please do not touch it. You need that area to be bypassed by the proximal plate as it rises up, and only contact the tooth kind of near the occlusal surface. Of course, heavily contoured teeth will have to be treated prior or recontoured prior to giving a proximal plate, because if you try to jump past too big of an undercut, then you're going to create a foot trap later on. If I do get a chance, I will probably show you a case with a bigger undercut later on. So let's just jump to the next step. Now it is going to ask me to draw the bar and the mesh. One different thing with 3Shape and ExoCAD or partial CAD is that in 3Shape you have different small steps where you draw each outline, it gives you a preview and move to the next step. Whereas with partial CAD you draw an outline and then you go to the next step and tell the system, okay, this is going to be my mesh, this is going to be my major connector, and so on. A slight bit of difference between the two varieties or the two systems, Alright, so I'm just going to go ahead and draw a rough outline. Don't need to be too picky. I usually prefer doing slightly artistic outlines. There is actually no functional reason or functional benefit of doing this. If you want to do it, you can, else you can just go ahead and just create a box between the buccal and the lingual slopes. Please do not go too much to the buccal, because then setting your teeth usually is a problem, because in partial cases, especially if you're working with Asian or Indian populations, you tend to have reduced intra-arch space as opposed to the Caucasians, who have a lot more intra-arch space than we do. So it's always better to have your opposing cast ready with you as and when you draw. So I've drawn the rough outline, zoom out. I can go ahead and edit them at this point, or I can do them later as well. Reposition your points as necessary, right? I'm just going to speed run through the steps right now, and then I'll probably give you like a fast forwarded way of how I finally refined my design as well, right? Don't want to waste too much time in perfecting it right now and waste a lot of time. So this is done, I'm going to kind of draw a so you can draw an open-ended curve for your mandibular major connector, but then I prefer to sometimes have an extension on the lingual so that I can kind of get a nice finish line over here for the extension of my acrylic. It again, as and when you design, you will develop a preference or a style of designing, and no two people's designs are the same. So go ahead and kind of explore what you want to do with the system. Make sure that you kind of lock your major connector and your mesh together, right? This step is kind of automated, or it asks you to do that when you're working with 3Shape, but then ExoCAD really doesn't throw you an error there. The Nexus system has already told me that these are the things that it wants to do. I will first create the mesh. If you notice, your retentive meshes have a preset pattern of a circular hole. You can go ahead and reduce the size of the holes if you want. You can also rotate them as you like if you have like a specific orientation. One thing is, make sure that these openings are not kind of too much near the edge, because those are areas of weakness where they might break. I always like to have a meshed rim, which is like an outline of this, so that the mesh is not open at these ends, right? So I've just toggled on the mesh rim, and this looks good. I'm going to tell the system that I want to do a connector. It's already outlined the major connector for me. You have the option of different surface textures. I'm just going to go with a smooth texture right now, right? All these things look good. Your fall off is basically how the borders of the major connector kind of merge into the edges. So a greater fall off will have like a slightly greater dimension as the bar merges from its thickest part towards the thinnest part at the border. We're not going to be doing those right now. We're just going to be sticking to the basics. I'm just going to say apply, and it is going to form down the lingual bar for me. And there we go. We have a lingual bar. So let's see, we can increase the thickness. This looks good. I have these artifacts which I will be cutting off later. Not worry about them right now. Alright, let's go to the next step. Now I'm going to draw the clasp curves, right? So first we are done with our steps for kind of outlining the major connector and the mesh. Now we're going to designate where our clasps are going to be. So this is going to be double circlets on both sides. I am going to do an eye bar on the other side just to show you guys what it looks like. Even though the design is for dual circlets, I'm just going to do it to show you guys what it looks like. Now of course, if this were to be an eye bar, I wouldn't have removed this particular part of the circlet or the blockout wax. It doesn't matter because my eye bar is going to go down cervically. It's going to be a gingival approach, right? So I also prefer to have my eye bars a little longer than what people typically do. Some people just like to curve them and approach the mesh near the cervix of the tooth. I don't do that because by nature your bar clasps are pretty rigid, so it makes a little sense to kind of lengthen it, because the longer the clasp is, the more the flexibility of your clasp and the less the potential for damaging the tooth. Once I've outlined my clasps, right, I am going to go to the next step and tell the software what type of clasps they are. So you can see the apply clasp step, right? I go here. So anterior is chosen and it is a single curve clasp, right? Because I've drawn the reciprocal and the retentive arms in one go. So I click it and you notice that a particular outline already forms. Now I can stay over these control points, hit shift, and it tells me the taper width, and if I do shift plus control together, it allows me to kind of alter the entire width in one go, right? So I have different outlines I can try. So you tell the system that this is going to be a ring, because one thing I like with the ring is that it has a uniform taper. Now if you notice in this particular case, you can notice that the ends are switched. In a clasp, you want your clasp terminus to be thinner, that is the part which contacts the tooth, to be thinner, and the origin from the mesh to be a little thicker. Settings, and you can see that there's an option to swap the ends and it automatically gets switched. So I don't need to sit and redraw the entire clasp. So that is not needed. I'm just going to thin down the clasp a little bit. Yes, 1.3 works. I don't like extremely bulky clasps. Clasps are better, manufactured in a slightly thinner state. So I'm just going to kind of blend this into this region and I'll just smoothen it off later on. And it is going to ask me to fill in wax. So fill in wax clone basically gives you presets of wax. So each of these particular mesh connector, minor connector has the different thickness and width of wax that is pre-programmed, and you can just kind of use them to draw wax in regions to form connectors and so. So say for example, I have occlusal rest. I'm just going to fill in the wax here, and there you go. Now since this is going to be a bar, I would prefer a mesial rest, which is what I'm going to do. Right, go here. You don't need to be too picky or too perfectionistic about your design at this particular point, because we will be kind of merging them all in later on. Should say minor connector, open up the brush a little bit, drop the thickness to about millimeter works, and just join this. don't worry about all these excesses that you see. You will be having a choice to kind of clean that up later on. Kind of merging everything in. And another thing I've kind of forgot to mention is when you're drawing your mesh, right, the curve for the mesh, if you outline a smaller outline within the outline of the mesh, that will automatically get detected as a tissue stop. So you can do that later on, but then I just happen to remember it right now, so you have that option for that as well. So I've done this, occlusal rests are drawn and my proximal plates are drawn, and there we go. So lastly, it is going to be the finish lines, right? So I'm just going to draw a rough finish line. I always like to start my finish lines at the proximal plate because it gives a nice starting point for my acrylic to stop at that particular zone, which at a lot of times is kind of forgotten. So you can see that the proximal plates are applied, and the cool thing is you can just kind of hold it and twist out the angle to kind of get it to the angle that you want. Yeah, this looks good. So usually you want it at a kind of a 45-degree angle so that the resin locks into that external finish line. So the next step is just completely about sitting and merging all your design parts. Now if you want to really take your work to the next level, you can add metal backed facings, metal crowns onto your design. So if you are going to do something adventurous like an onlay clasp, you can design an onlay in partial CAD. That design will be stored here on the left, right? And if you notice, I can import a particular pattern, right? And once I choose solid wax, it can kind of get imported into the software as an editable part, and I can basically have that in my design or incorporate that into my partial design before going to the next step, which I'm not going to be doing that right now, but then I'm just letting you know that that particular option is available for you. Step is just going to be edit wax, where I'm just going to go ahead and sculpt and kind of smoothen everything down. So I'm just going to kind of fast up or speed up this part and show you what the final product looks like. So what I'm just doing is using the combination of the smooth and smudge tools to just get rid of all the artifacts and any excesses that I don't need. Your best friends would of course be smudge to erase pieces of wax, and the smooth tool, especially the flat smooth tool, so which is the first regular smooth, to kind of flatten out any bulges that you don't need. Don't overdo it, right? Kind of make or keep an eye on how much of reduction you're doing, especially with the smudge, because the smudge can just take away a lot of the wax at times. So be a little careful, and do not ever touch the profiles of your clasps. They are preset and should be left as such. And there we have it. We have a decent looking partial, we have our finish lines, we have a mesh, and we have a major connector with the RPI system of clasping here and circlet on the side. So this is how you build a partial in ExoCAD. Of course, the design could use a lot more refinement, but then this is basically how you do it. I might probably do another video on some special tools, digital sprueing, placing the tissue rests, maybe tissue stops maybe on that particular design. And if you want some particular design explained in detail, or you want something talked about, please do drop it off in the comments so that I can kind of incorporate it in the next video. See you guys.